Hello everyone, my name's Terry, and in this video we're going to write out conjugate acid-base pairs and identify which compound is an acid and which one is the base. And there's three main definitions of what acids and bases are. We're going to talk about the Bronsted-Lowry definition, in which an acid is a proton donor. So it gains an H, technically H+. And a base is a proton acceptor. Make that in green here. Proton acceptor is a base. Now there's the Lewis definition of an acid and a base. For the Lewis definition, that's an electron acceptor for an acid, and a Lewis base is an electron donor. And then there's also the Arrhenius definition of acid and base. But when someone mentions acid or base without saying what type of acid or base is, they typically are talking about this kind right here, the Bronsted-Lowry definition. So acids are proton donors and bases are proton acceptors. And that's exactly what's going on here. So if we look at this SO3 2-, this is sulfite, it turns into this. So it gains an H, and the charge changes. And it does that by gaining H+ total. If we look at this sort of a half reaction, this SO3 2-, if we add H+ to it, then it turns into this HSO3 because they combine. And the charge, we have a charge of -2 here, a charge of +1. So the net charge is -1. So here, this SO3 2- is called a proton acceptor. Should put it in green. So it's accepting a proton. I'll just say accepts a proton. And the reason we say proton, remember, hydrogen. So hydrogen has a proton in the middle, can have a neutron as well, or a couple neutrons. We want to call it deuterium or tritium, but anyways, it's we have a proton and you have an electron going around. Now it doesn't really go in an orbit, right? There's clouds of probability based on quantum mechanics, but it's a proton with an electron. Those are the main charged species. If you remove the electron from hydrogen, then it's basically you just have the proton in terms of its charge. So we call it a proton in there. So it's a proton donor because it's accepting H+, so H without its electron, essentially. And that's what makes it a base. So this is the base because it's accepting a proton. So that's the base. Now, bases react with acids. Acids react with bases. So if one is a base, then the other one is an acid. A base is a base because it reacts with acid. The base accepts a proton. It's got to accept the proton from something, and that something has to donate its proton, wherever it gets its proton from. So whatever's donating this proton, that's the acid. So that's the base, that's the acid. And what happens is when the base and the acid, when they react together, they kind of flip what they are. So the base turns into an acid, a conjugate acid. So this is now the conjugate acid. You know what? I'll keep it in green because they're in pairs. So this is called a conjugate acid here. So the base turned into the conjugate acid, and the acid turns into the conjugate base. Now, why is this important? Well, remember this reaction, it goes both ways, right and left. Well, these products here, this HSO3- and the OH-, these can react together and go back into here. And the way these react is this one's going to act as an acid. It's going to be a proton donor. And this one's going to act as a base. So originally when our bases and acids react together, we also create another set of acids and bases as well. And we can look at this going the other way. You just basically flip, you can just flip this arrow right? You can, if you go the other way with, maybe I'll make it in red. If we go that way, it's donating a proton. It donates H plus anyways. So if it donates H plus to go this way, then it's an acid. So that's the conjugate acid. And when the base turns into an acid, we call these pairs. These are conjugate acid-base pairs. So here's a conjugate acid-base pair, and here's a conjugate acid-base pair as well. Okay. So I think we identified that. Let's do this next one here. We'll do it a little bit less messy because we went over quite a bit of theory already. So we have HPH3, phosphine, turning into this pH4 plus. Well, it's gaining a hydrogen. I'll make it green because try and be consistent here. So it's gaining an H plus. See how it's neutral? If it's gaining a positive charge, it's now positively charged. So this is a proton acceptor. So if it's a proton acceptor, this is the base. By default, this H2PO4 has to be an acid. And if we look at what's happening with this acid, go from here to here, it's going from H2 to H, so it's losing a hydrogen. But it's not just hydrogen, because if you look at the charge is going from -1 to 2 minus, so it's becoming more negative. Since it's becoming more negative, it loses a positive charge here. So the base turns into the conjugate acid, conjugate acid, and the acid turns into the conjugate base.